Hello students, welcome to Vyas Education Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 12th. The chapter that we're dealing with is integrals, and now is the turn of exercise 7.4. Now this particular exercise is based on some algebraic integrals of the form 1 upon x square minus a square, 1 upon x square plus a square, 1 upon a square minus x square, and similarly their under root forms. Along with that, we can also solve linear upon quadratic or linear upon root quadratic. All kinds of those things can also be solved over here, right? So along with the questions, we'll be seeing the formulae, right, and the methods which we want to use over here. So coverage of theory will go alongside the problems. That's what we'll be doing over here, right? So let's begin the first question, which says, okay, you have 3x square over x power 6 plus 1. Now this is not a direct question, but this is an indirect one, and the first thing that you can observe over here is, okay, this is x square, which is actually the derivative of something called x power 3 over here, right? Yes. So I observe that I have 3x square over x power 3 square plus 1, because I am interested in a quadratic in the denominator, right? A quadratic in the denominator can be solved easily. This exercise is based on that, but in future also when you encounter such questions, a quadratic in the denominator, only a quadratic in the denominator can be solved easily, right? But that formulae, that is the aim. So let x power 3 is equal to t, and that tells me that 3x square dx is equal to dt. Therefore I becomes equal to 3x square dx, which is dt, upon x cube, which is t, this is t square plus 1. Okay, this is a direct formula. This is equal to tan inverse t plus constant of integration, right? Okay, and it finally leads to tan inverse of t. T is x power 3 plus c. Now this is the formula that we have used over here, and that gives me the final answer. Integration occurs at this stage. Substitution obviously is a part of integration only, but the formula that we have used over here is integral of 1 upon x square plus 1 dx is simply tan inverse x plus c. A more generalized version would be integral of dx upon x square plus a square. This is equal to what? This is equal to 1 upon a tan inverse x upon a plus constant. This is a more generalized version when you have a square along with x square, right? Instead of x, if you have a linear function, linear polynomial of x, like instead of x, if you have px plus q square plus a square, the answer would be 1 upon a tan inverse px plus q upon a, and you also have to divide by a p over here, right? That is something which you have seen, right? If instead of in the formula, if instead of x you have a linear polynomial of x, then at max the one and most important thing that you want to do in the end is dividing by that coefficient of x, right? So this particular formula is useful over here, yes, and along with that we have solved the solution. We have solved this particular question using that particular formula along with substitution, right?